Welcome to Spring LIB.
So here, since we're dealing with rotational motion, we can use torque equal to moment of inertia times the angular acceleration to find out the angular acceleration. Now, for the moment of inertia for a sphere, for a uniform sphere, spinning about its axis will be 2.5 m r squared, where r is the radius of the sphere and m is the mass. So if we know that there is a frictional force of um, let's call that tau f. So the reason we're calling it tau f is because we're dealing with, again, rotational motion. So that force is 0.02 newtons. So if we know the frictional force and also if we know the moment of inertia, we can figure out the angular acceleration from this equation. So the angular acceleration due to friction will be negative 0.02 newtons times 0.015 meters. And the reason we're multiplying this is because we're given the frictional force. So this is really torque. Torque is really frictional force times the radial vector, which is 0.015 meters. So this is just a multiplication, it's not a cross product. So we'll just multiply one with the other. So our frictional force is given as 0.02 newtons, and from there we get the torque as we multiply the radial vector. So that's the torque. Then for the moment of inertia, it's 2 over 5 times the mass, which is 0.225 kg. Then we multiply that with 0.15 meter squared. Combining this, we get the angular acceleration is as negative 14.8 radian per second squared. Now we know the angular acceleration, and I guess that's what we need in part A. For part B, we need to find out the time it needs to decrease the rotational speed by 22.5 radians per second. So we can actually write the final omega, or final rotational velocity, or final angular velocity. Let's call it omega z minus, let's call it omega OF, which is the initial omega, and that the difference should be equal to negative 22.5 radians per second. And the reason there's a negative sign is, again, because it's decreasing. Also, we can use omega z equals omega OZ plus alpha z times t equation to find out the time, because from here we can write omega z minus omega oz, which is equal to alpha z times t, which is equal to omega z minus omega oz divided by alpha z, which is equal to time. And we know that this difference right here is 22.5 radians, and this guy right here is negative 14.8 radians per second squared. So using the numbers, we see that t is negative 22.5 radian per second, and z is negative 14.8 radian per second squared. So t becomes 1.52 seconds. So we need 1.52 seconds to decrease the angular velocity to 22.5 radians per second. Thank you.